got 15 seconds. Ooh, this is loud, hot. Can you guys hear me well? Absolutely. All right. Who cares about 10 seconds? All right, so next up we have Chahak Mehta. He is a software engineer at Arch Labs in New York City. Likes to read and learn about the random things happening in the tech world. So he's going to give a talk about LSP Demystified, which I know nothing about. So I'm hoping to learn just like you are. So welcome.
Yeah. Hello, my name is Chahak. Thank you. I am a software engineer at Arch. I work from New York. I'm flying in, and that's my GitHub. Today, I'm just going to talk a little bit about my experience of writing a language server using Python. I wrote one for MySQL. So this is aiming to be an overall overview talk with a few examples from that language server. And for that, before starting, I'd like to start with a quick poll. How many people in the audience use VSCode? Roughly 70 people. JetBrains IDEs, Vim, NeoVim, Emacs. Yeah, so most of us have seen something like that. That's autocomplete. We've used that for everything that we type on. And the image shows an example for autocompletion for print using the based towrite language server. And it shows different options that we could select and the documentation for the print function. What else? There's this thing. It shows a linting error. Now, in our editors, we would often see like, if there's an unused variable that, OK, it's telling me that this variable is not used, and we should probably either remove it or use it, right? So how are these errors and how do these autocompletes show up on our server, on our editor? And all that is courtesy a language server. So building an integrated experience and having these insights for different languages in IDEs would require their own framework. So earlier, every IDE, so if you had VSCode, Emacs, anything, if you had Eclipse, they had their own language servers, so to speak, behind, which would look at the code that you're writing and understand it and give you autocompletes, for example. The language server protocol provides us a unified framework which helps us implement all of these features in all these languages, and now it can be decoupled from the editor. For example, if you see the first figure, if there were nothing, no language server, and we wanted to introduce a new feature, say autocomplete for Python, we would have had to go and inside VS Code and each of the editor and implement it for the language. On the other hand, with language servers, we implement it for the server, and every client, so every editor that has a complete language server client just automatically gets that ability. So this requires us to do only one unit of work on the language server and not have to deal with every single client. So this makes it easier to introduce more new features. So what is language server and how does that work? So a language server is basically a stream of messages. You can think of it as an API, is a server with multiple API endpoints, but it uses the JSON RPC protocol for communication. And the structure for these requests and responses are defined in a set specification, which is what the language server protocol is. That is what LSP stands for. And it was introduced in Microsoft in 2016. It was then later made into an open standard with Red Hat and one more company. But this image is taken from the specification page from Microsoft, and it shows a quick example of how this communication works. So we have a language server and a development tool, which can be any editor that you're using. And if you open a page, if you open a file, it'll send a text document, did open notification, and so on and so forth based on what the user is doing. If the user is opening a document, if a user is editing the document, or if you want to go to definition for a function. So a language server specification defines the set of capabilities, as they call it, as a server provides that works on a document, the entire language as a whole, on a workspace or a window. The examples on the image show did open, did change, publish diagnostics, and definition. Now, each of these capabilities have a defined specification for request and response. For example, if you ever done go to definition on VS Code, that calls the text document definition endpoint method on the language server, and it takes the ID of the request, the parameters that are required, which are just what symbol you want the definition for, and the method which lets the server know what definition it needs to use, which here is text document definition, and just the JSON RPC version. For the request's response, the client will expect a response with the definition link, which will determine where in which document and where the position of the definition exists. So this is just a quick overview of what kind of requests and responses do the clients and the servers expect. And once we have set this basis of communication, the server now needs to understand the code base to be able to respond to any of our requests, right? If you give it a document, it'll just see the entire file as a string file. So this requires parsing the files into an abstract syntax tree, and this is largely backed by the use of language grammars. For example, in this particular code snippet, SQL Fluff is a Python library that provides grammars for different dialects of SQL, and it also provides parsing and lexing abilities. Similarly, I'm sure a lot of people here attended Charlie's talk in the morning about rough. Rough is a linting tool. It does something similar. It first lexes the code, parses it, and then performs linting operations. So just like how rough does it for Python, SQL Fluff does it for SQL queries. We can now use this library that already exists to parse our query. So for example, if we just have select star from help category, that's a default table in the MySQL schema. We can parse it using the lexer, parser, and then parse it. Once we have this, we can now start applying linting tools. So linting tools can be applied on the abstract syntax tree, and these linting errors that we can determine, that can then be sent to the client to show errors. This is done by the text document publish diagnostics method. And in this example, for example, it shows how to do this with SQL Fluff. So SQL Fluff provides its own set of linting rules, and we just leverage that here because there aren't any standard linting rules for SQL. Publishing these linting errors into a server is very easy. As you can see, all it requires is create an object of the diagnostic type, and it just takes in the range as to from where to where in the document is the error coming from, and what kind of an error is it, along with what code. OK, I'm not sure why it's not showing up there, but a simple function called ls.publishDiagnostics, oh, it's right there, sorry. Publish diagnostics takes in all the diagnostics and then just puts that into a JSON form, and it goes directly to the server, to the client. Now the client can handle this set of errors however they want. Sometimes they can hide them initially and only show them when the user wants them, or they can just auto show whenever they show up. For example, this is what that query would have shown. So it would have showed us that query produces an unknown number of result columns. And so if you see that it's underlining just the select part, because that's where the error comes from, that the select part of this query has an error. So this is the linting aspect of it, which is basically backed by having an abstract syntax tree of the query. All of this is well and good, but one of the basic feature and probably the most used feature of language servers are autocompletion. How does this work? Because every time we type, it gives us some autocomplete. So every keystroke is sending a request, and we are getting a response. Having set up parsing and linting, we can now easily provide smart autocomplete. What does smart mean here? It means that suggestions can vary via context. So in SQL, for example, if you are typing select star from HEL, you expect that you'll see different table names that start with HEL, right? But on the other hand, if you are typing select HC dot and you had everything else determined, you would expect it to show what column names are inside the table help category, which is alias-HC. So this is context-aware autocompletion, and this requires us to have existing underlying knowledge, which is where the AST comes in. So once we have the syntax tree, and once the request comes in about where the cursor position is, we can determine where in the syntax tree it is and make suggestions based on that. So for example, to handle these two cases, we could have something that's very simple like that. Sorry for the big code blob, but that's the smallest I could do. So if you look at the first half of the match case, it's just if you're in a columns segment, then you would look at the alias of, or if it's an alias, you can look at the table name and get all the columns for that table. Or if you're expecting a table reference segment, so you just want to give all the tables. So fundamentally, it's not a very difficult problem. But once we solve this up and we have it inside the LSP loop, then we can easily surface that information to the user and have a nice user experience. Once we have this, it's that. Okay, sorry. So once we have that set up, it allows us to have a well-defined user experience, and we can use autocomplete for wherever we want. The next thing that autocomplete, if you remember the first example, is it did not just show us completions, but it also showed us documentation for each of those completion requirements. So suggestions. So how does that documentation come in? So a language server specification allows us to show definitions by two ways. One is with the autocompletes, where we can, if you look at the documentation key, you can send in any description of the autocomplete suggestion, and it'll show it up as a separate window. The other thing that it also provides is a hover capability. Now, so if you see, like, the text on the screen is not extremely important, but if you see, the cursor is on a function called override, and if you are hovering on that, you'll see a different window, which will show you the entire documentation for the function override. As a side note, if anyone's doing the Python challenge bingo, that's a 312 feature that's present on presentation slides. So that's probably 1 point. But yeah, so this allows us to surface documentation without having to go look up documentation on docs or web pages and such. So we can directly look at what variables we need to pass as arguments. So this example is for the override decorator, right? So all of this is well and good. What else? This is not just all that is provided. The spec is very big. There are various things that it allows us to do, things like code action. Code action is basically custom code commands that we can do. We can run code using code actions. If you've used Rust Analyzer, they can allow direct running of the Rust code. There's formatting. So you can use the language server to format the code itself. And there's organizing imports. You can use isort. So if anyone of you has, I'm assuming most of you, has used Python LSP server, then each of these capabilities are also inbuilt on the Python LSP server. So all of this is courtesy the language server protocol, which allows us to surface that very easily. But all of this is on the server side. How does the editor actually do it? As I previously said, it doesn't have to do much. So for example, if the client is well spec'd, I'm an Emacs user, so this is an example with eglot. I had like a 10-line patch that I needed to add to make it also run SQL queries and all of it support the SQL server that I was writing, and that's it. Like nothing else needs to be done on the client side. So incorporating new language features is as easy as implementing it on the server, and then the client just automatically gets it. So I have a quick demo. Bear with me. So if you can see, oh, no, you cannot see. That's, sorry, one sec. Now you should be able to see. If you can see here, this is the same, this is essentially the same query, but I can do this, and now I have this entire, I just increased the font size, so this is not very useful, but you can get this entire description of the table as hover, right? Now, the autocomplete, so you have this. So you can see the entire table information. Again, the format is all wonky because 40 point. But you can see that it's a table, or if there's something that's a keyword, and depending on what the context is, it'll give you that suggestion higher up. So if we did category as HC, and for this, so it gives us this name option higher up, as it's the column from help category that we are looking at. And there are also two other keywords from SQL that are also a match. So it shows up the documentation for those two too, including the syntax and description. Mind you, none of this requires anything other than that 10-line patch on the client side. Everything is handled just by the server doing it right. So this is one example. Bear with me while I reduce the font size, because that's a lot. And if you also want to then just run the query, live demos, am I right? You can do various things like explain the query. So this is straight up MySQL explaining the query. Or you can even execute the query. So if I were to run execute query, it's going to show me the result of that query. All of this is happening straight up inside the editor. There's nothing else. It's directly interfacing with MySQL underlying database, and there's no other layer in between. So you can run queries like this. You can run, it basically runs any queries, because it's just like any other SQL editor. So this allows us to, and this was my motivation, it allows you to use your normal everyday editor and not have to go to a separate database client to do anything database related stuff, and then have to jump back in. So you can even do things like switch connections. So if you had like a test database, and if you had a prod database, then you can switch connections based on what you want to test, and then it's as easy as that. So that was a quick demo. And as a summary, what needs to happen is you take in the code, you parse it, depending on what all information you want to surface, you either provide linting diagnostics, you provide smart autocomplete, and ... There should be like, you can do basically anything with the custom code actions, and it all comes to the client. And all of that goes into the language server, and that's it. Like every client can have that capability as long as the client is a complete language server client. So it's as simple as that. Yeah. Any questions? Yeah. Sorry, server what? The server is just running, so I can actually just show it to you.
There's microphones back here. There's microphones back here for the questions, just so you know. So this server is just a binary. Binary. It's in Python, so it's a script, and it just runs in the stdio mode. It uses the very, very nice library called PyGLS, which provides the framework for everything else. Server. So if you're interested in the code, all of this code is on GitHub. It's all, I wrote it over the last few months. It's all available. I use the LSP protocol and the PyGLS library, but it basically runs in stdio mode, so it's just taking in from standard input and just putting it out from standard out. Any other questions? Yeah.
How do you distribute a LSP on PyGLS, and what do you use for end-to-end unit testing?
I'm sorry, could you repeat, please?
How do you distribute an LSP built with PyGLS?
Right.
And then how do you do end-to-end unit testing?
Okay, so this is just another Python package. So you can actually just go pip install SQL LSP, and it'll just get you the binary. Like it'll just get you the library. Once that is done, this is very nascent. So I have only introduced Emacs support. But if you are using Emacs, it's as simple as adding these 2 lines, and then it'll just work. Does that answer your question? Any? Yeah.
Thanks for the talk, very interesting. When you're doing like slightly more complicated analysis,
Right.
does like firing an event on every key press introduce like performance issues? Do you have to do some kind of debounce or something? How do you deal with all that?
Yes, if you've used the TypeScript server is notorious for being not very good. That's one of the reasons why, because especially in VSCode, it sends request on every keystroke and on every mouse event because everything is a hover. So one thing that's something that ends up happening on client side. So whichever editor is doing that, it's their responsibility. So for things like Vim and Emacs, it's nice because not every mouse event goes as a hover. But every keystroke, so for me, if you noticed when I pressed NA, only then did it show me an autocomplete. So you can set that up. So for me, it's like if I press 2 characters, only after that show me something. Otherwise, don't show me anything. You can set it based on how your preference is. Yeah. Yeah. I'll just repeat. The question was if I can show you guys the GitHub repo, which I can. What's going on? It's in full screen, right? It's not extremely fleshed out, but it's basically all here. The code fundamentally is the server file, which defines all the different capabilities, so to speak, so things like text document completion, what happens when it opens, when it changes. So at every point, you want to be publishing diagnostics. And what happens if you want to format the query, what happens if you're hovering on something. So the server file is where each of these are defined. And there's a separate file for completions, which does all the completion. Yeah, it's all on there. It's also updated. So if you guys are interested, you can take a look.
Just 1 second. Can you go up to the top so that people can just copy down the name and zoom in a little more?
Yeah, so the slides are also on my GitHub repository under PyCon. So it's also a text file. So all my slides are also a text file. So based on your preference, and if you have any other preference, find me and I can share those things with you too. Yeah.
So LSP, it looks to me like it's extensible. Like you can add different sorts of events maybe that may only apply to certain languages. Like for your execute query example, like it doesn't seem like something that you would do in Python or something like that, but it works for SQL. So you can be extensible with it?
Yeah, so especially with the code action, that provides us this ability to put in any type of action that we want to give it. So for Python, it can be organizing imports. That can be a code action. Or it can be rename a symbol. So those are different code actions that could be only for Python. But for queries, that's not really the point. So for them, you can have like run the query or explain the query or analyze it. And since the text document code action definition is fairly open, you can just have that request and response and let the server handle however you want it.
Perfect, thank you.
Yeah.
Oh yeah, is the code actions part of the protocol?
Yeah.
Is that robust enough to do refactorings, like rename a variable, or something like more complex than just organizing imports?
Yes, so it can also do renaming and refactoring variables, which is actually something that Pyrite, Rough, and Python LSP, so all of them provide the ability to do that. That's basically, since you have the abstract syntax tree, you know the exact you know the exact locations of those symbols, and since you know those symbols, you can rename all of those in one shot.
Cool. Thank you.
Any other questions? Okay, if not, if you guys want to chat, please find me. I'll be walking around, and we can let the next presenter take over. Thank you, guys.